Hello, and welcome to a short lecture on the basics of arrays in Scala for Introduction to the Art of Programming Using Scala. Up until this point, you have learned how to create variables, and those variables refer to single values. Even if you make something a var, for example, we could make a variable b and set it equal to 8. You can change the value by doing an assignment, but b refers to a single value. This is somewhat limiting. If we had 100 different values we wanted to store, we could create 100 different variables. It would make programming very tedious, but it would be possible to store all the values that we wanted. We're now going to start learning about some things called collections, and collections give us the ability to store multiple values inside and give them a single name. So the first collection that we're going to learn about is the array. Arrays are fairly ubiquitous in programming. Lots of programming languages have them. And in Scala we can make an array. At least the simplest syntax is to do something like that. Now this makes, we say that we want to have an array and we pass it arguments, which is a comma-separated list of arguments, and it creates a new array with those values. We gave it a name, and the type here, you'll note, is not just array, but the array is followed by square brackets. This is what's called a type parameter, and we can read this as an array of int. Scala looked at all the values that we passed in and said, yep, those look like ints, and created the appropriate type for us. We can, of course, give names to our arrays. So we might create an array called nums, which has, for example, 2.6, 3.14159, 7.8, 42. Now technically that 42 was an int, but Scala looks at all of these values and says, you know what, that 42 is also a perfectly happy double, and so it says that nums is an array of double, and it stores those values inside of it. We could also make an array of names. So this might have things like Mark and Jason, Kevin. Now an array is a type of collection that's called a sequence, meaning that these values that are in here have a particular order to them, and when we access them we do so by giving their location in the array. So in the case of nums, let's say we wanted to get the first element in here. Well, we pass it an argument, just as if we were calling a function, and we give that, what we pass in is the index. And indexes in Scala and many other modern languages are zero referenced, meaning they start at 0. So the first element in nums, this 2.6, is at index 0. If instead we ask for index 1, then we get the second element in there. Index 2, index 3, and those gave us all the different values. So the indexes are always between 0 and the length of the array minus 1. Arrays can also tell us how long they are. We have a method in them called length, and so nums tells us that it has 4 elements in it, whereas names tells us that it has 3. Arrays are what are called mutable, and what this means is that we can change the values of certain elements in them. So while I made both nums and names as vals, so the name nums refers to this array, and it will always refer to this array, the array itself can change values inside of it. For example, I can do that. And now if we look at nums, nums has a first element of 99. which is kind of what you'd expect given this syntax. This is only possible because arrays are mutable. That will be a very significant term, as will its counterpart, immutable, going forward, so it's worth taking note of it. Now, while the values in an array are mutable, the length of the array is always the same. You cannot add elements to the beginning or to the end of an array. There are operators that will do things like that. However, that doesn't change the original array. Okay, so once you've created an array, it has a fixed length and it will always be that length. It's also worth noting that this operator, which adds to the end, and then its counterpart that adds to the beginning, are both very inefficient, and you should not use them too much. You'll also notice that some interesting things happened here with our types. Scala did not like the fact that we used integers there for putting those in. So, this syntax that we've looked at, where you just say array and then give it the values, that's fine for small arrays. But once again, if we go back to the I have 100 values or I have 1,000 values or whatever, that's really not going to be ideal. There's an alternate syntax that allows you to create very large arrays. And that syntax, we use the keyword new, and we follow it with array, and we have to tell it what type of array we're doing. So if I make an array of ints, and then I have to pass it a value for how many of them I want. So let's just say I wanted 20. And we get an array with 20 integers, and they all start off as zeros. Now, exactly what you get from this syntax depends upon the type that you are building. So for example, if we make an array of doubles, we get a whole bunch of values of 0.0. If I make an array of Boolean, I get a bunch of false. If I make an array, if I made characters, they would all be character 0. That doesn't print so well. But it's worth noting, if you make an array of string, for example, you get this thing called null, which null is basically an invalid reference. It does not point to any object. For that reason, we will wind up not using this approach much, but we'll have to learn a little bit more before we can get into other ways of making large arrays. So at this point, let's go ahead and let's edit a script. And as you can see, I've put in some comments for some functions that we want to put into this script. Given what we know at this point, the way I want to have us go through and do things with all the elements of an array. The first function that we'll write fills in all of the elements. And we're going to write this recursively. So we'll write a function called fillArray. Our fillArray function, well, it needs to know the array. And because they are easy to work with, we will use an array of ints here. We also have to pass in the value that we want to fill it with, which, since this is an array of ints, that value needs to be itself an int. And then we're going to pass in an index, which is where we are in the array currently. Note there is no return type, and there is no equal sign here, because this function is not going to give us back anything. Instead, it is going to simply alter the array that is being passed in. So, in order to write a recursive function, first thing we need to do is decide what the base case is. I'm going to make this function so that it starts at low indexes and keeps going up and bigger until it gets to the end of the array. Now, when we run out of bounds, it turns out that we want to do absolutely nothing. So the base case here is actually being greater than or equal to the array's length, and it's kind of going to be an implicit base case, because I'm going to say if index is less than arr.length, then I'm going to do something. Okay, so if it's not less than, we're not going to do anything. We're done. If it is less than, well, then what do we want to do? Well, we want to fill in that position, that index in the array. We want to make it equal to the value that we're filling in. And then we want to move on to the next element of the array. So we're going to recursively call the same array, the same value, but now index plus 1. Because our base case, we're going to keep going as long as this is small enough. Eventually we want to get too big, and so we count out of range. So to see this in action, let's go ahead and let's make an array. I'll call it nums. It is a new array of int, and we can make like 100. Okay, just something big enough that we wouldn't want to have to type it in by hand. And I want to use the function we just wrote on that array, and I want to fill it in, say, with 5s. Okay, originally all the values were 0, now they will all be set to 5s, and I want to start at index 0, because that is where the array starts. And then we want to print the array. Now, we're going to get some unexpected behavior there. If we run this, it does indeed print something, but it really wasn't what we were expecting. We wanted to see a whole bunch of 5s. Turns out that arrays don't print nicely in Scala. This actually goes back to the Java implementation, and there are lots of details behind why exactly this happens. This up here, that bracket I, is telling you this is an array of integers, and then it has this nice number which is in hexadecimal, which hopefully at this point you recognize that is a possible hex number that is a unique identifier for it. Unfortunately, that tells us nothing, at least in the sense of what we wanted to know. We wanted to see that we had 100 values that were all set equal to 5. So that prompts us writing another function. We need to have a function to print out our array. Def print array. We're going to pass it in an array, our array of ints, and it also needs to know the index for the value that it is currently printing. We have the exact same base case here. As long as the index is less than arr.length, then we want to print this value, and I am actually going to just do a print arr subindex, and I'll follow it with a space, as opposed to a print line. That way they all get added on one line, and I'll have to remember to do a print line when we are done. Actually, I guess I could make that my base case. And this is not the base case, so this one is going to recur print array, same array, index plus 1. And what we were just saying is that there is a nice base case for this, which is that when we are done printing everything, we can do a print line. Instead of doing print line down here, let's call our print array function and start at 0. And with that saved, we can run this over here and see, indeed, we have a whole bunch of 5s. Feel free to pause and count them all, but feel very confident. There are 100 of them. Okay, what if instead of filling every value with, or every element of the array with a single value, we wanted instead for these to come from user input? Well, turns out that's a fairly straightforward thing to do. We pass in the array, we pass in the index, and the code's going to look very much like the previous fill. As long as index is less than arr.length, arr subindex equals read int. Then move on to the next one. Read array arr index plus 1. I really don't want to do that with 100 values, so how about we make a smaller array, new array of int of 5. Just 5 values, that way I can easily type them all in. Read array, small nums, 0, print array, small nums, 0. Let's see if that works nicely. I didn't put in a prompt, so it's waiting for me. I'm going to type in 1, 2, 3, 4, 5. And we see that that is what prints out here. So, as you can see from my comments here, there's one other function that I would like to write. So all of these functions up here weren't really calculating anything for us. They were just altering the array or printing the array. These other functions were basically based on side effects. They were doing something for us. I want to do a calculation as well. I would like to have a function that adds up all of the elements of my array and returns the sum. So I'm going to write this function called SumArray. It takes our array of ints. It also takes the index, but unlike the others, this is going to return an integer, because the sum of a bunch of integers is also an integer. Our base case here, and I'm going to make it explicit, if index is greater than or equal to arr.length, we've run out of things to add. And when you've run out of things to add, that means that your sum is 0. If you still have things to add, though, then the sum should be the value of the current thing plus the sum of what is left afterwards. So if the index is greater than or equal to the array length, we give back 0. Otherwise, we give back the value at the current index plus some array called on the same array and all of the indexes after this one. And we can show that this works. Print line nums, print line small nums. So we will get two different sums out. See all of the 5s. I'm going to type in 3, 7, 1, 2, 2, which should give us a sum of 15. That was not what we wanted to print, was it? We want to print the sums. Sum array nums, comma 0. Sum array small nums, comma 0. Try that again. 3, 7, 1, 2, 2. So the 105s adds up to 500, exactly what you would expect. And the second set of numbers we can see adds up to 15, and that is what our code gives us. So that is a brief introduction to arrays, how we can make them, both the short arrays and longer arrays, the indexing into them, both for getting values out as well as for assigning values into them. The assigning values in works because they are mutable. And then we wrote some functions to play with these. And it's also worth keeping in mind that the arrays do have a fixed length. So while we can change values that are inside of them, we cannot change the length of the array itself once it has been created. We'll have more videos on related topics soon. Thank you.